All right, in this problem, we got Wiley, and he's going to be falling off a building. Now you notice this is a picture at different time intervals. So this is Wiley at time equals 0. Here's Wiley at time equals 1. It's like they took a picture every second. It shows you where he's at with location to a number scale here. All right, so here's time equals 2, etc. So what we're going to do is we're going to go ahead and fill this chart out based on where he's at, time and position, and then we're going to find average velocity. From average velocity, I'm going to show you how to find final velocity. Again, most of it's actually review. So, again, it's pretty straightforward. So time 0 is at 0. Time 1 is at, looks like 5. Time 2 is at 20. And so let me go ahead and fill that chart out over here. Switch over here. So 0, 1, 2, 3, 4, 5. And then we got our positions. Again, he's over there, he's at position 0. He's at 5. Then he goes to 20. Over here at position 3. 1, 2, 3. He's at 45. If we scroll down, he's at 80. And his final position is about 125, like so. Right, now this symbol here, what this thing means here is average velocity. And how we calculate average velocity, we're going to do it two ways. The first way is actually from unit 2, and to find average velocity, you can take your displacement divided by your time. So all we have to do is take this, the y, how far we've gone, divided by our t. So that's 0 here. 5 divided by 1, so that's 5 for 1, which is 5 meters per second. 20 divided by 2 is going to be 10 meters per second. Now you'll start to see there's a pattern forming, 0, 5, 10. Sure enough, 45 divided by 3 is equal to 15 meters per second. And that's 20 meters per second. 125 divided by 5 is 25 meters per second. Now from this, we can actually go ahead and find the final velocity. Now how we do that is the other definition of average velocity, and that is if you take your initial velocity plus your final velocity and divide it by 2, that gives us average velocity. Alright, so now what we want to do is we actually want to find final velocity, and to do so you take both sides times 2, and then you subtract over your initial velocity. So what you end up with is final velocity is equal to the average velocity times 2 minus your initial velocity. So we come over here, well, our average velocity is 0 here, so 0 times 2 minus our initial, which is 0, is 0. Now we'll do that for this equation right here. So VF is equal to 5 times 2 minus our initial velocity. Since it's free falling from a cliff, you're just dropping it. Your initial velocity is 0. Not in every case will it be 0 though, just for this one because it's from, like I said, it's because it starts here like this. Now you can shoot it up and it'll still be free fall. And we'll get into that problem, I think, on worksheet number 2. We'll address that there. So that's equal to 10 meters per second. We do that same thing for this one. So that would be 10 times 2 minus 0. So that's going to be equal to 20 meters per second. And again, you see a pattern forming. And sure enough, if you follow that pattern down, you get 10, 20, 30, 40 meters per second, 50 meters per second, etc. as we go down. Again, what I want you to recognize here, why I'm doing this, is I want you to recognize the pattern. And in the pattern here, it's exponentially increasing. 5, difference between those two. And it's going to 15, it's going to 25, 35, 45, exponential increase. Well, this is going at a linear increase where it's going 5, 10, 15, 20, 25. All right. So the next part of this thing is to draw a graph, y versus t. And so to do so, just straightforward, make sure you use your final velocity for this graph. And that's actually on the sheet there, but I don't like to use it because it usually doesn't work right for me. So here's our 5 seconds, and every 5 seconds going up by 10, 20, 30, 40, 50. And so our v versus t graph looks something similar to that. Okay. The next part is says write out the equation for the graph above. Again, a lot of people hear the word equation, they freak out. Don't freak out. We know how to do this. Y equals mx plus b. So our y is velocity final. Our slope is rise over run. So that goes up 50 meters per second divided by 5 seconds, which would be 10 meters per second squared, times time, which is on your x-axis, plus 0, in this case, as our y-intercept. So our equation is VF equals 10 meters per second squared times t. Then it says use your graph to determine the acceleration. Well, we know from last unit that acceleration is defined, acceleration is slope of v versus t. Right, so we've actually already solved that right here. So the answer is 10 meters per second squared. Now, you might have a problem with that because I said the acceleration due to gravity is always negative 10. Well, you got to use your scale for that, and why it ended up as positive 10 is as simple as this, is that going down this time ended up being positive. Notice the numbers are increasing, and so it ended up being 10 positively because the numbers are increasing going down. Normally that's not the way that we do our scales. Normally we start as ground zero and go up instead of starting at 0 up here and going down. And so that's why this ended up being as a positive. You just got to keep your head about you and which way your scale is to determine whether it's negative or positive. But in general, we'll make it negative. And again, that's just based on the scaling. It says using your graph to determine the displacement for the first 3 seconds. Okay, so we're going to use the graph. Remember, displacement, graphing-wise, is this area from here to here. So that's 1/2 times 3 seconds times 30 meters per second. So that's 90 times 1/2, which would be 45 meters. And then part 4, it says, use equation 1, cross that out. That's a typo. And put in equation 2. Use equation 2 to determine the displacement. And what this is establishing is that our mathematics from Unit 3 all work in this case. Okay, so equation 2 is delta y. Notice instead of using delta y, or delta x, I use delta y. The VIT plus 1/2 AT squared. And so you got delta y is equal to 0 times 3 plus 1/2 times 10 times 3 squared. So this goes to 0. So delta y equals to 9 times 10 times 1/2, which is 45 meters. And those two answers line up as they should. And showing that our equations and our graphs still are the same from last unit. Okay, I'm good.